Hello, welcome to another ramble.com. We are chatting about November 2023 IEB's paper 1, and today we're looking at question 10D. Consider the geometric sequence given x, y, x plus y, and so it goes, where x is a positive number and y is a positive number. Determine the numerical value for x over y. Okay, so I tell you right now, this is one of those questions where I am not seeing the path right from the jump, but I am going to start by doing what feels instinctive, which is to we want to find some equation to solve. And what equation can we generate from this? So you want to try and stay away from introducing new variables unless you have to. You already have x and y, so you don't want to now be doing an a is equal to x, and then a times r is equal to y, and then ar squared is equal to x plus y. Like, that is a lot of variables. Unless, okay, you could do some clever things like subbing, not like that, like saying that, okay, this is ar times r, so I can sub in this y over there, and then it's just yr is equal to x plus y. But yeah, I'm not feeling that, because I'm just like I'm not bringing you into the chat unless incredibly necessary. So another way to think about this problem is to say, well, okay, we know that because it's geometric, the following is true: y over x, okay, term 2 over term 1 is equal to term 3 over term 2. Okay, that much we know. So this is a geometric, this is an equation that is in terms of two variables, x and y. So it's not giving me warm fuzzy feelings, honestly. I would like to get another piece of information about, two unknowns means, we need two pieces of information in order to solve the problem. So I don't know if it will be sufficient to say that x plus y over x is equal to whatever r is squared, because that's, you've times by r twice to get there. I think it might just take us back to wherever this is. I'm just going to erase it for now and see, maybe if I'm more desperate than I already am, I'll come back to it. Okay, so cross multiplication, our friend, y squared is equal to x times x plus y, which is x squared plus x y. Interestingo, amigo, is all I have to say about that. So y squared is equal to that. Yo, where are we going, guys? Where are we even going? Consider the geometric sequence given. Oh wait, okay, so wait a minute. So another way to think about this, this is me still being very lost. Y over x is equal to x plus y over y, which is the same as x over y plus y over y, which is the same as x over y plus 1. Okay, so we have y over x minus 1 is equal to x over y. I don't know how this profits us, but it did make me excited ever so temporarily. Because at least now we've got an expression where, you know, x over y is showing up. But yeah, it's still a bit of the pits. It's still a little bit of the pits. Determine the numerical value for x over y. Okay, so let's see. Y over x minus 1 is equal to x over y. So why can I not figure out? Oh, but y over x is the r. It's the common ratio of the thingy of the ring. It's the common ratio of the sequence. Okay. I don't know if life is getting better or worse. What's going on? This is me now, just like being lost for words. Okay, so S3 is going to be x plus y plus x plus y, which is 2x plus 2y, which is 2 times the sum of the two terms. Does that take me anywhere? Does it, my brothers and sisters? Does it profit me? I do not know. I do not know. Let me see. So let me just carry on with this series tangent. So S2 would be the A is x, the R is y over x, to the power of n, which is 2 minus 1, divided by y over x. And the S3 is, the S3 is, again, x is our A, y over x is our R, okay, and divided by y over x. Okay, so I'm just going to simplify these a little bit. So this would be dividing by y over x is just the same as timesing by the inverse. So this will be the same as x times x over y, and over here we have y squared over x squared minus 1, which is x squared over y times y squared over x squared minus 1. And over here we have the same thing, x times x over y times y cubed over x cubed minus 1, So that would be x squared over y times that, right? Which tells us, oh, I have a feeling we're ending up in the same rabbit hole. So we know that S3 is the same as 2 times S2. So x squared over y times all of that is equal to 2 times x squared over y, y squared over x squared minus 1. And we can disregard these guys, right, because they're the same, so they're not really moving the needle. So this is then y cubed over x cubed minus 1 is equal to 2y squared over x squared minus 2, right? If I multiply the 2 there. So can just add 1 on both sides. So we end up with y cubed x cubed is equal to 2y squared over x squared minus 1. Okay, just going to move this term. So we have y cubed over x cubed minus 2y squared over x squared is equal to negative 1. So if I put these over the same denominator, y squared minus, okay, so we need to times the bottom by x. So that means we need to times the top by x. Ooh, this is just getting hairier and hairier. It's not giving solution, honestly. It is honestly making me feel like this would probably be more useful if we just deal with it flat. So I'm just going to times both sides by x cubed. So that is y, and this is y cubed. Eesh. Minus that is equal to negative x cubed, and then y cubed plus x cubed minus 2xy squared is 0. Oh, I don't know if that's taking us anywhere. I don't know if it's taking us anywhere. So I am just going to pretend that didn't happen. Honestly. And then it's gonna turn out this is like a walk in the park, and I'm just going to cry. I'm going to be that little piggy that cried all the way home. Consider the geometric sequence given where x is greater than 0 and y is greater than 0. X, y, x plus y. Determine the numerical value for x over y. Yay! Okay, so let us just okay, I'm just gonna move the stuff because there's stuff that I feel like did not really move us in any useful direction. So I will not erase it, I will shrink it because I can afford to not erase it. But in an exam, oh, I would rip that page out in a blink of an eye. Okay, I'm getting an idea. Sort of. Okay. My idea is, suppose as one of my science teachers last from the past would say, okay, that was definitely not one of my suppositions. Yeah. Some Shia, US Orbantu. Damn, man. Why God be just you? Just you. We will come back for you another time, my friend. Okay, so this was coming from this. I love how, I'm mostly, I remember why I am storing these to begin with. It's so that if I make a mistake, I can come back and point at what exactly I made the mistake. Okay, I was just thinking that it's so silly for me to store these notes when they are really not even in a state for me to share them with anyone. They are so haphazard. Okay, so here's what I started thinking right in the midst of cleaning up. I started thinking, no, I did not want to take a screenshot. Delete it right this moment. I started thinking, okay, suppose that somebody told me what X is. They told me that X is 2, for example, right? How would I use this information that I've been given to figure out what Y is, right? So I would know that, okay, X times R is equal to Y, and X times R squared is equal to X plus Y, right? Or let's just say, because we're working with 2 here, right? I want to find a Y that would make, or find an R, find an R that would, make both these things work. Okay, so maybe let me go back to the symbols because the numbers are not really giving me joy. Or maybe let me park that on the side. Okay, I don't know what I just undid, but anyway. Okay, so that is an idea. We can just keep it in the back of our minds. Right? So we're saying X times R is Y, and X times R squared is X plus Y. And XR, okay, is the same as Y, R, is equal to X plus Y. Okay, but that's also just the same as, so XR is Y, and YR is X plus Y. Okay. So X over Y, right, which is just the same as XR over YR, is equal to Y over X plus Y. These are the same. These are the same. I mean, they have to be. Does that take us anywhere at all? Y over X minus 1 is equal to Y over X plus Y. So we have y minus x over x is equal to y over x plus y. I don't know if this is doing anything for us, but let's prevail with the madness. So xy is equal to x plus y times y minus x. So that's again doing our favorite thing in the world, cross multiplying. So that is xy minus x squared plus y squared minus xy. Okay, difference of square situation. So that is y squared minus x squared is equal to xy. CRP, CRP, CRP. I don't know where we are going. I don't know where we are going. I know, I know, I know. I don't know. This is just another idea I'm going to park on the side. This video is just going to be 30 minutes of me fumbling. How many marks was this question even? Oh, guys, Hi. Don't spend 30 minutes on this question in an exam. For those of you screaming through the screen, the answer is right there. Open your eyes. Please bear with me. Maybe now you'll believe me when I tell you that you're such an average mathematical brain I am. Okay, but I'm just gonna highlight some breakthroughs. We know that. We know this. Oh, I mean, yeah, okay, we already knew. So this result is the same as what we just saw, right? Just written differently. Okay. If you move the x squared to the other side, you get xy is equal to y squared minus x squared. So there isn't really a new potato there. Oh, guys, my heart and my soul. Maybe if we use a different color. So let's see. Okay, let's go back to numbers. Say x is 2 and y is 3. So then x plus y is equal to 5. So let's see what this looks like as a sequence. So that's 2, 3, 5. How far are we from arriving at Nirvana? So that's 2 times 1.5. And that is 3 times 1 2/3. So almost, but not really. Okay, let's try another pair of numbers. Let me actually just move this guy up. Yeah, it's moving with my numbers, guys. It's too late. It's too late. In fact, yes, you shouldn't even be so tall because you're confusing us. Okay, you are confusing us. us being me. Okay. I hope there's an inspiring story waiting on the other side of all the suffering, because, well, it's giving chest pains right now. Okay. So we are there, but we are almost there, but not really. I'm going to tweak the 3 so that it's something a bit smaller. I'll put 2.5. But then that's going to shrink this and increase this. That's not what we want. We want to increase this a bit and shrink this a bit so that they can meet, right? Because this is currently times 1.5 and this is times 1,6 recurring. So if this can just go up a little bit and this one go down a little bit, maybe they'll meet somewhere. Okay, so let's see. Maybe let's say so let's increase this, right? Maybe let's increase it to wait, what to do? Yeah, okay, let's increase it to 3,2. So 3,2. So 3,2 divided by 2 is 1,6. Okay. And 5 divided by 3.0. 5 divided by 3.2 is 1,5625. So this became too big, right? So we want to make it a bit smaller so that this is a bit smaller and this is a bit bigger. Okay, so let's do that adjustment. So let's try with 3,1. Okay, so 5 divided by, okay. 3.1 divided by 2 is 1,55. And then 5 divided by 3.1 is definitely going to be such a weird number. So that's going to be times 1,61, blah, blah, blah. Okay, so we made it too small. Okay, so this is not the process I really want to do. Also because X and Y could be many things, right? Because we are just looking for an X and Y. I mean, I've just kind of fixed what X is, but X could really start anywhere. It could be 1, it could be 1.5, it could be 10. And then the Y would just have to behave a little bit differently. But so technically, there's possibly like infinitely many solutions here. So let me park this somewhere as well. In the graveyard of ideas. Not a graveyard. Such a horrible... Don't be mean to your ideas, okay? Never be mean to your ideas. Okay, so we can't really graph this because these don't really look like graphs we typically work with, do they? Because, okay, what we know is that the relationship between X and Y is, you could either look at it as Y squared is equal to X squared plus XY, which is not a circle, right? Because minus X squared plus Y squared is equal to XY. It is not a circle. A circle wouldn't have this negative coefficient here for your X squared. And then there's also like these little weird XY terms. Your circles have the x's in one corner and the y's in one corner. They don't really interact with each other like this. So I can't graph that. And the alternative way to look at the relationship is like this, which is also something that I cannot graph. But the point is that there are potentially infinitely many x's and y's that satisfy that satisfy this condition. So it's not really about solving for what x and y is. It's about finding the ratio between them. Oh my God! Oh, the pain. Oh, the pain in my spleen. Oh. Okay. So this is indeed, and this, oh, golly, wolly. Okay, so we have, and I think the liberation is coming from realizing that we don't actually have to know what x and y are exactly. All we care about is x over y, what that is. And we already know that y over x is the ratio, it's the common ratio for this pattern. X over y is just the inverse of that. It's just the 1 over, right? X over y is 1 over y over x, right? Because 1 divided by y over x is just the same as 1 times x over y. Ooh, I'm getting excited. Right? So we can use that relationship to our advantage. Okay, let me write that out again a bit less angrily, a bit less kicking myself in the buttily. Wow, I actually wonder how long it has been. Oh my goodness. I should probably put a timestamp to say, listen, if you don't feel like agonizing with me, this is where the answer is. Okay, so y over x is equal to r. We also know that x plus y over y is equal to r, which we can also just write as x over y plus y over y, which is x over y plus 1, right, is equal to r as well. Okay, so y over x is equal to r, and x over y plus r plus 1 is equal to r as well. But we also know that x over y is the same as 1 divided by y over x, right? So that means that it is the same as 1 divided by r, right? Using this little fact over here, okay? Or in other words, 1 over r. Okay, where is this taking us? I got so excited. I got so excited, and then, oh, okay, where it is taking us is, we can then say that using this, okay, we can now write an equation just in terms of r. Yes, that's where it's taking us. Okay, so, okay, let me just highlight where what is coming from. So I'm going to highlight this in pink. Okay, and say, well, y over x is the same as r. Okay, so that's where that is coming from. Now we are going to take this equation, okay, right, and say therefore x over y, which is the same as 1 over r, is the same as 1 over r plus 1 is equal to r. Okay, so we're using that green highlighted fact to replace the x over y we're not using, okay, we are using the green equation to write this. Okay, so these are the same. Okay, and they are the same because we have discovered that x over y is equal to, in a very long-winded way, 1 over r. Okay, it is the inverse of the ratio which we find to be y over x. Okay, and now we can solve. My goodness. Okay, some people don't like this thing of timesing by the denominator. And okay, I think it's safe to times. It's not safe to divide. So what I mean by that is if you have something like x squared is equal to 2x, okay, you should never do this. Never divide by an unknown because unless you know that it's not 0, it's definitely not 0. Otherwise, you could be dividing by 0, right? Because now you will arrive at, okay, that means that x is equal to 2, which is one of the solutions. But another solution to this equation is in fact 0. So what you're encouraged to do instead is to rather than either take things to one side and then factorize and all of that. But all being said, it is absolutely fine to times through by an unknown because if the unknown is 0, then it's a problem that it was here to begin with. But anyway, all to say timesing is safe. I always get confused. I always catch myself before I go ahead and do it. So we can times everything by r to get this guy out of the denominator. So then that'll just be 1 plus r is equal to r squared. Okay, so that is a quadratic equation that we can't factorize. So we're going to need to use the quadratic formula. So r is equal to wait, let me just make a note for myself here. A is 1, B is -1, and C is -1 as well. So that is minus 1 plus or minus -1 squared minus 4 times 1 times -1 over 2 times A. So that is 1 plus or minus, in here we end up with 1 plus 4, which is 5, divided by 2. Okay, but we were told that x and y are positive, so that means the common ratio must be positive as well. So r is positive, right? So therefore r is equal to 1 plus root 5 over 2. Okay, and remember r is y over x. Okay, so we now know that maybe what shall we do here? Maybe let's just add another page in between here. Can I do that? Oh, I can do it here. Yes, perfect. Right, so we know that y over x is equal to that. Okay, and so therefore x over y will be the inverse of that. You can flip the fraction around, or 1 divided by this, which would result in the equation, the fraction being flipped around. But yeah, essentially it's this. And if we were to rationalize the denominator, okay, we would times by 1 minus root 5, again, something you can just do on your calculator instead of agonizing your soul. So that will be 2 minus root 5, and over here we'd have 1 minus 5, and that would be 2 minus 2 root 5 over -4. This negative results in a switcheroo at the top. Okay, so these two switch around. Okay, and then of course we can factor out a common 2. Okay, and down here we'll have 2 times 2. So your final answer just becomes root 5 minus 1 over 2. That is the ratio between x and y. Okay, right. So this is the magical ratio that would give us a geometric pattern that looks like this. And in fact, this is literally the golden ratio, isn't it? Let me just double check this on the interwebs. Well, okay, not this one. Not this one. This is the golden ratio. I'll double check now on the internet. And the golden ratio is a special number that turns up in all sorts of places in nature, the number of petals on a flower. Okay, let me kind of rewind. Okay, the golden ratio is a ratio that turns up, but among many other places, it turns up in the Fibonacci sequence. And looking at the sequence now, I'm just like, oh my goodness, of course. Fibonacci sequence is a sequence where the next term is determined by the sum of the two previous terms, right? So if you have 1 and 1 as your first two terms, then the next one is 2, the sum of these two. And then the next term will be 1 plus 2, which is 3. And then the next term will be 2 plus 3, which is 5, and so on. And what they have found is that as this sequence goes and goes and goes, the ratio between a term and the term before it becomes closer and closer to this number, the golden ratio, 1 plus root 5 divided by 2. And so it makes complete sense that that is the ratio that would show up in this geometric sequence. Yes, and there's also some fascinating things about the Fibonacci sequence and the golden ratio, sorts of beautiful images developed by using that ratio. Apparently, people who have the best looking teeth, subjective as that might be, the ratio between the width of their teeth is the golden ratio. So very fascinating number, very nice number to bump into at the end of such an arduous journey. But let's talk about, what just happened in the last hour of agony? So the starting point was to take the information we had been given and try and figure out what is an equation, what is a relationship that I can write down based on this information. And we know that geometric sequences are sequences where there is a common ratio between each pair of consecutive terms. So we took that information and we wrote, y over x is equal to, so y over x is equal to x plus y over y. This didn't really do it for us, so this wasn't a very useful way to look at it. But thinking of it this way, where we split up the fraction so that we had x over y plus y over y, or x over y plus 1. So now we had an equation that was connecting y over x and x over y. And I think I was so fixated by trying to find a second equation so that I would be able to solve for x and for y. But really, we were just given one piece of information at the end of the day, sort of, kind of. And we don't really need to know what x and y are to answer the question that was asked. So the obsession with finding a second equation was a very futile one. The nice thing that was sitting right underneath our noses all throughout this is that y over x and x over y have a special relationship. So first of all, we know that y over x is the same as r, and we know that x over y is the inverse of y over x, so this is the same as 1 over r. And that would allow us to solve an equation, which is also like, So essentially, no matter what your x and y are, as long as the relationship between them, the ratio between them is the golden ratio, then this is what the relationship between the first, second, and third term will be. The third term will be the sum of the first two terms, which is an interesting thing to arrive at. Anyway, so I'd say a couple of morals to the story for me is definitely just keep trying avenues. To keep trying to express the relationships, express as many relationships as you can using equations. Think about numbers, doing it in numbers. Actually, what was interesting about, I don't know if I still have it, this season of the Troubles is, these numbers are kind of hovering around the golden ratio. If you actually go ahead and work out what the golden ratio is, it's 1 plus root 5 divided by 2. It's about 1.618, whatever. So the toggling that I was doing, trying to adjust these numbers so that this one's a bit higher and that one's a bit lower, eventually I was going to find the perfect numbers around 1.61 when the ratio turned out to be 1.618 something or something close to that. Anyway, so in an exam setting, these are the kinds of things that at the very least make me panic and I'd get very anxious. So I definitely wouldn't spend as much time as I did in this video. I wouldn't spend that much time on the question. I would proceed with other questions, also because the brain is so powerful. In the background, it could be maybe, kind of trying to process this information a bit more and knock on a bit more doors in your brain to figure out, do you have anything that could help me figure out this question, etc., etc. But yeah, I think maybe an even bigger lesson for me personally is to also just be open to the idea that two unknowns doesn't necessarily mean we need to find out what exactly the unknowns are in order to solve whatever question has been posed. So that's also an important thing to bear in mind is, do I have to actually solve for x and y? Anyway, okay. A real ramble. I think this is what this channel is in earnest, is me genuinely being stumped and trying my best to put all of my thinking on paper. And as you have seen, the thinking was wide and varied, was very chaotic. But that is the beauty of mathematics for me, is just struggle and satisfaction. Okay, cool. Catch you for another chat some other time. Peace. Welcome to an afterthought. And this afterthought comes after having actually gone and looked at the memo for the solution. I was so confident that I was right at last after, almost an hour of looking at this question. And I just want to, after having looked at the memo, I'm like, oh my goodness, okay, so I kind of wrote this interpretation off, and actually this is the interpretation that, by this I mean this whole spiel, is actually the interpretation that the memo uses to arrive at its answer. So let's quickly look at how they went about it. So I'm just going to duplicate this page and get rid of as much as possible. Wait, actually I just need to move it. I would like to move it. Can I move it? I can. Okay, I want to move this one then. Okay, right, so that the original solution is, yes, okay, so now, but now we don't have a question. Oof. Okay, this is a bit disastrous. Why did you, oh my goodness. This guy remained here. Okay, let's see if we can move you to where you belong. Okay, lots of scribbling. Okay, this is not working out well at all, so I am just going to say cancel and undo as much as I possibly can. Okay, is everything still looking sensible? Yes, okay. So let's just put this question here afresh. So this was the question, and let me see if I can grab that first approach that I wrote off. Let's see how successful we can be here. Oh, okay, copy over there and paste over here. Okay, not bad, not bad. Right, so okay, so yeah, the initial approach that I had was to again just start by expressing this y over x is equal to x plus y over y. So that's the relationship, the common ratio. And then cross multiplication gave us this equation ultimately. So then what they do in the memo from there is they then say, okay, so x squared plus xy minus y squared is equal to 0. And they treat this as a quadratic equation where a is equal to 1, b is equal to the coefficient of x, which is y, and c is equal to the constant, in inverted commas, which is negative y squared. So they solve for x, right? Because if they can find an expression for x in terms of y, which is what we're going to get, then we can get an expression for x over y easily. So not a bad trail of thought at all. Very decent. So we've got negative y plus or minus y squared minus 4ac divided by 2 times 1. So that becomes minus y plus or minus y squared plus 4y squared. Ooh, this is already looking very nice. So that is minus y plus or minus 5y squared over 2. And this we can just write as minus y plus or minus y times root 5 over 2. So we now have an expression for x in terms of y. Okay, so therefore, okay, but also do we need to consider both these solutions actually? So we know that y is positive. Okay, so I'm just going to make this more explicit. So we are looking at x is equal to minus y plus y root 5 over 2, or x is equal to minus y minus y root 5 over 2. And okay, so this one, I mean, just to make it abundantly clear what's going on, if I factor out the minus, we're just left with y plus y root 5, or actually it would be better if I factored out the y. So this would be y, and we'd be left with minus 1 minus root 5 over 2, right? And we can make it even more explicit and say this is minus 1 minus root 5 over 2 times y. And similarly for this one, we can say this is minus 1 plus root 5 over 2. So this is minus 1 plus root 5 over 2 times y. If we work this out, but even just from the eyes, we can see that this is a negative number. Minus y minus 2 comma whatever is a negative number. Divided by 2, still negative. And because we've been told that y is positive, that means that this would be a negative number overall. You know, so, but y is positive, okay? And we know that x is positive. They told us in the question x is positive. So the only valid solution would be this one, right? Because this number, if we punch that in, but also just from intuition, 5, square root of 5 is bigger than square root of 4. Square root of 4 is 2. So square root of 5 is 2 comma something. If you minus 1 from that, that's still positive. So that means this whole number would be positive, and this whole number would be positive because y is also positive. So actually, the only valid solution here is that x is equal to negative 1 plus root 5 over 2 y. And so the ratio between x and y, which is what we were asked for, would be negative 1 plus root 5 divided by 2 y divided by y. And of course your y's will cancel, so then we end up with root 5 minus 1 over 2, which is what I think we ended up with previously as well. Yes, root 5 minus 1 over 2, which is also what the memo gets. So yeah, I just thought that was quite a cool approach to the question as well, you know, that it is still a quadratic equation, right? Just not in the conventional form where we just have one unknown, but it's quadratic because your highest exponents are 2, and not only that, if you just look at the equation in terms of x only, so your y could have been y to the power of 10 for all we know, but in terms of x, if you treat y like a constant, then in terms of x it was a quadratic equation, and so quadratic equation applies, quadratic formula applies. Anyway, just thought, yeah, that was quite a cool way to look at the question, and also me apologizing for writing this off as a dead end. It in fact was not a dead end. Cool.